So I have some things we're going to be hacking on just to show you some key capabilities, but we're going to be telling you a story as we go throughout this presentation. And actually, we're going to start with a personal story. By the way, you'll see some Bruce Lee quotes in here. He's a childhood hero of mine. But hopefully we're going to have some fun, and we're going to be hopefully hyperactive and energetic. That is my style. You guys maybe have seen that before, and then it'll be interesting, I'm sure. But let's start with a little personal story, okay? And this personal story starts actually with Hawaii. I actually grew up in Hawaii, or was born in Hawaii. So I actually was Hawaii and Alabama, Hawaii. And I went back and forth a lot. So I'm actually from two worlds, if you will, biracial, two worlds, two different worlds. But I was just in Hawaii just a little bit ago. I was visiting family at that time. And I went to go visit Oahu, Honolulu, but also the Big Island of Hawaii itself, which is the one you see in the lower right-hand corner there. And when you see where it says Captain Cook, that's where I was hanging out. So on the Big Island, I was along this left-hand side here. And the reason I was there is because that's where my family is from. That is where my ancestors are from. And my mother grew up there as a Kona coffee farmer. So she was a coffee farmer. So we actually stayed right down there in the Captain Cook area. That's known as Kealakekua Bay. We stayed right at the bay, which is a beautiful bay, one of my favorite places on the planet. So Kealakekua right there. And it's really awesome because you can actually rent a little house just down off this little road you see on the right-hand side. And you can kind of see where my camera's facing. I actually took this off Google Maps with my phone when I was sitting right at the side of the bay. And this is what it looks like from that angle. So you can't really see the Captain Cook Monument out across the bay there. The bay is actually quite huge, but that Captain Cook Monument is actually where the English captain first landed in the islands and discovered this group of people called the Hawaiians for the first time. And so that was about 1779. So over 300 years ago when that occurred. There's a lot to that story. We won't have time for it now. But this is where I was staying because this is where my mother was from. This is where she grew up. And what's really cool about that bay, one thing I really love about it, is there's dolphins that will visit that bay. And I actually got out there to swim with these guys. So this is literally my video that I took of them. And I just turned into an animated GIF. So I love the fact there's great marine life. You can go with the dolphins. There's lots of great fish. There's great snorkeling. And you can just kind of hang out in that bay all day if you want. And I also love this Bruce Lee quote here. You must be shapeless and formless like water. I think the quote applies for the dolphin imagery there. But I want to make really this point. In that bay, there's a pier. And this is a picture of the pier. It's just right, not too far from the other picture where I took the dolphins. It's an easy walking distance of about 2 minutes. And that pier is where my great-grandfather came over from Japan. So in 1892, he came from Japan and landed at this location. The pier didn't look like this back then when it was just sailing vessels back in the day. But he landed there to be one of the very first Japanese people in the islands of Hawaii to start a coffee farm. So over 120 years ago, he started a coffee farm, and this is the point of entry where he came in. And so that was quite an adventure for him, right? My great-grandfather left his home and basically tried to be an entrepreneur in a foreign land, in this case, in the middle of the Pacific, in this island of Hawaii. This is the family that remains there today. So this is my Uncle Mel on the left, my Uncle Billy on the right, my Auntie Jessica right there also. So this is actually an older picture where I went to visit them last time. But in this case, I went and visited them just recently. And this is my wife visiting one of my Uncle Mel, looking at over his garden. You can see it's very jungle-like because it is very much. This is just up on the mountainside from that bay. This is my son being taught how to make sushi with my Auntie Jessica here, teaching him how to make some food, which is cool. So he's learning how to make food Japanese style, and my uncle talking to my wife in this case. And this is actually my uncle teaching my son how to pick coffee because it was coffee picking season. And my uncle continues to pick coffee to this day. It is one of the longest running Japanese coffee farms in the state of Hawaii and, of course, all of America, and one of the longest run Japanese coffee farms in the world. I think it's one of two at this point because my uncle continues to pick coffee. And I wanted my son to do that. And he was interested in that. So he spent the day actually working on the farm out there picking coffee. Now, why do I tell you this long story? One, I come from some very interesting beginnings, but that's not really the point. The point was a long time ago when I needed a computer, okay, and this is in the 1980s, I needed a computer because I was interested in learning about technology. And I actually had to call my grandfather up, not my great-grandfather, but my grandfather, who was the coffee person, and say, I need a computer. And this is a man who picked coffee his entire life. All right. That's all he knew. And I don't know what a computer at that point cost in terms of coffee. It was probably like a month's worth of coffee picking, if not 2 months worth of coffee picking at that point in time. But he didn't even know what a computer was. And he just had a question for me as a proper Japanese grandfather is this for school? And the answer was yes. And he sent me the check so I could buy my very first computer. And it was an IBM like this one you see here. And of course, it had the 2 dual floppy drives, which made it super cool. No hard drive at that point in time, right? We had to go with dual floppy drives back in the day. But I got my chance to get on a computer. So this was a game changer for my life. This fundamentally changed the trajectory of my life because I thought I might just go off and do something else. I didn't know that computers made money. In the 80s, we had no idea that you could get a job and make a great living with those computers. Now, here's another great quote. Don't fear failure, because it's not failure, but low aim that is the crime. In great attempts, it's glorious to even fail. So I want you thinking about that quote from Bruce Lee and thinking about my story as how I got access to a computer because it was game changing. Because now I want you to imagine just for a moment. So just take a moment. Don't have much on this slide for a reason. To think about that moment where you got your chance to touch your first computer. In my case, it was 35 plus years ago, sitting in a classroom in Hawaii. And of course, then talking to my grandfather who got me the computer so I could do it on my own. And I would stay up all night on that computer. I would sit there typing commands into that computer because it was just a DOS thing back then. You know, there was no Windows at that point in time. And I would give it commands. I would see it respond, give it more commands and see it respond. And I would write a little bit of code. And that code would then come back and run and say, hello, Burr. Or maybe it would say hello, Burr multiple times because I put it in a loop. But the point is, I discovered a magical superpower at that point in my life. I could type commands into a keyboard, text into a screen, code into an editor, and then compile it and run it. And it was the moment of the running that I discovered that superpower. And I think all of you had the same experience if you're in this career path today. You might have been 2 years old or 6 years old or 45 years old. You might have been at summer camp doing this for school, doing this at a church event or some form of community event. You might have just simply been doing it at your house because your mother or your father thought it was a good idea, but someone gave you access to this really weird device called a computer, and you were able to type stuff in, compile it, and run it. And it's the running part that was the magic. And if you take anything away from this presentation today, I want you thinking about that aspect of running, because it's the running, it's the ops that matters, not the typing, not the coding. Don't care how good your syntax is. Don't care how pretty your semicolons and curly braces line up. It's the running that matters. And as developers, we have to get back to running. And because that was the magical superpower we gained back in the day. All right, so let's keep going here. Let's talk a little bit about some other ancient history, not my personal history per se, but I did see all these things unfold. So in the 1980s, we have what we call the Chewy, or I call it the Chewy, the character user interface. It was a VT100 or 5270 or 5250 or 3270. And back in the day, we actually had that form of communication tool with our end user. In other words, it was a green screen or amber screen, and it was a very simplistic tool. And the weird part about that IT infrastructure back then, there was a human dedicated to operating the computer and using the computer. Other parties that, let's say it was a manager who actually needed to interact with you, would actually talk to a human. That human probably would type out a fax. The fax would go to a back office person. And when I say fax, people might not know what that is anymore, but there was this thing called a facsimile or fax machine back in the day. And then that person would data entry that data in. So back in the 80s, there was like 3 humans involved for a single transaction, because that's the way the technology worked. And then in the 90s, we came up with this concept of the graphical user interface. This is where Windows was born, Microsoft Windows. And in the world of Windows, we actually thought, well, it's so easy to use now. And we can actually build laptop computers and desktop computers for people that they could actually type the data in themselves. So in other words, we actually could eliminate a person from the equation because the graphical user interface was easier to use. And we learned something about architecture in that point in time. We actually invented this term called client server. And it was kind of cool because on the client, on that Windows computer, we could use Power Builder or SQL Windows. We could use Visual Basic. I used to be working with a company called Progress Software, and we actually had a GUI Windows client server architecture. And it would use TCP/IP to connect across a network right? You would actually put wires between your computers and you would connect to a database. So client and server, client on the computer, client on the rich client side of that computer, and then the database on the server. A simple two-tier architecture, but that's what we did in the 90s. And we had to actually make sure that ran. And guess what? When we built that Power Builder or SQL Windows or Visual Basic app, we actually had to get it deployed to all those different client desktops, which was a big pain in the butt. We would walk around with our little diskettes and plug those diskettes in. And so even as a developer, I might be out there working with the different end users, making sure that the software got loaded correctly onto their machine, the appropriate drivers were installed on the Windows machine, if they had the TCP IP stack, because it didn't come for free back in the day. You had to install the TCP IP separately from Windows. All that had to be configured. But that was part of the operational concerns of seeing your application run. Now, in the 2000s, right, the early 2000s, the web really took off, all right? And the web changed things yet again. Because instead of having all that stuff on the client desktop and running around with a diskette from desktop to desktop to desktop and doing installations, because it was on the web, we could install it on a server and use this thing called the internet. And the browser on that client desktop could interact with it. And it was primarily Java and .NET. Those were the two big things of the day. There was a little bit of PHP and some other, various technologies out there at the time. But Java and .NET really kicked off at this point in time. And it was still client server, if you will, but the client was on the server. The database was still separate, but the client was now running on a server, running through a web server, an application server that served those HTML bits and actually dropped that HTML on the client-side browser. Now, here's a key element to this, all right? This is my other key punchline for this whole presentation. In 1999, if you wanted to be a Java-based web application developer, and you were in school, or you were trying to do something for your local community, or you were just a student trying to figure something out, or you even worked in a big corporation, and many big corporations certainly were adopting Java at this point in time, you actually would spend about $500,000 for Hello World. Hello World cost you $500,000 back in the day. Now, for most of you who have not been around that long, you're thinking, what is that guy talking about? But I'm telling you, I was the guy that would have sold this stuff to your boss back in 1999, and I did. Okay, I was out in the world in 1997, 1998, 1999, explaining to developers and architects and big bosses of the day, this web thing was real. Yes, you could go to the shopping cart called Amazon and buy books online, but guess what? Everybody's going to do everything online one day. And I had to convince people of that, and it turned out to be true. Now we have Facebook and Twitter and all that other magical stuff, Instagram, etc. But the point is, you had to spend a lot of money just to get started. You needed these Sunboxes, you needed a WebLogic, you needed an Oracle database, which cost a fortune. You even paid for your IDE. See the Semantic Cafe right there, which was the best IDE of the day, was $50,000 for 10 developers because you had to pay for the tools you used. Now, again, this is mind-blowing, but can you imagine the friction that created? The average student could afford this. The average person, even myself, couldn't afford this. You had to work for a big corporation to afford this particular element. Okay. Now in the 2010s, the architecture changed again, right? We started just in the last few years introducing this thing called Angular and React and Vue. And what we've done is we've gone client server all over again. We now have a fat client, not running on the Windows machine per se, running inside a browser like Chrome or maybe Safari. But now we have that element running on the client side that is talking client server to the server side with that middle tier, a 3-tier architecture now, and of course still the database. This is the most common architecture we see in the last few years. Now things have changed again in the 2010s. We have this concept of mobile. So we went from the world of always Windows-based desktops where everything was Windows. And if you go back into the 2000 timeframe again, 85% of the client-side devices in the world were Windows. Fast forward till now, and then only 20% of the client-side devices are Windows. The 80% are now Android and iOS. So the world has shifted dramatically, and the world of mobile means that an end user no longer has to call a human, no longer has to go to a desktop to input that into a desktop computer. They can walk around with their mobile device and input the data. And this changes the way we build applications now because we have to think in terms of providing proper APIs for potentially rich client mobile apps. But it doesn't matter how they're written, but that mobile app with its intermittent connectivity might actually have to interact with our remote API and of course connect to our data and input that data. And of course, things changed dramatically. I actually built this slide many years ago, and it actually runs from 2010 to 2011. But I was trying to make the point at the time that the world was changing dramatically, that the explosion of devices coming into the market was going to fundamentally change the way we think about applications. And this slide really is, at this point, 8 years old or 9 years old, I think, at this moment. Now, what's going on into the future? Well, you've heard about the Internet of Things. You've heard about this concept of the edge or the industrial Internet of Things. Certainly that is happening where we no longer even need a human, that things input the data themselves, that things produce sensor data and actuator data, and have this kind of crazy architecture where we have this concept of a remote gateway, we have sensors and actuators in the field, that data is collected through various wired and wireless technologies, and then of course it gets ingested into a big back-end infrastructure where we perform real-time analytics as well as non-real-time analytics, and that information of course produces dashboards and workflows and integrations. But the point is, the architecture continues to get more complicated, and we as software developers have to think about how this will run. And that's the point of this whole presentation. You have to think architecturally, you have to think about what it means to put it in production, you have to think about what it means to make it run. Okay? Now, one thing I love about this slide, this is actually a slide I also did many years ago. Several of these devices are no longer in production, no longer available. But when I was researching this concept back probably about 6 years ago now, there was an amazing explosion of things. So much like the mobile explosion which happened about 10 years ago, now we have an explosion of things. And so in the early days of a market, you see so many things being born, and then consolidation happens over time. Like in the case of the mobile universe, we now know that Android and iOS are the winners. In the case of the microcontroller universe, it's hard to know at this point. There's still a great diversity in microcontrollers. But then there's also the concept of embedded Linux. And like the Intel Edison, which used to be my favorite device, is no longer even available. The Intel took it off the market. The Raspberry Pi is still out there, though. And I don't even know about some of these others, how well they're continuing to do in the market, like Chip and Onion Omega actually came from Kickstarter campaigns. But you could do so many amazing things, and these things were inexpensive and more accessible. And so that's a key element of what we mean in our presentation here. When it cost you $500,000 to get started, very few people got started. Now it's vastly cheaper than ever before. Now, I love this Dilbert cartoon. I decided to throw it into my presentation. Normally, I don't use a Dilbert, but think about this for a second. If we migrate the enterprise to the cloud, use analytics, IoT, and DevOps for all services, the entire company can be managed by one monkey. And if you know a Dilbert, right, there has to be 3 panels. So in the third panel, plus a second monkey to look at the PowerPoint created by the first monkey, because we all have to have slides, right? Just like we have now. But I love this concept because the magic of all these things happening in the cloud, AI, ML, analytics, IoT, DevOps, and of course now SRE, these terms, these buzzwords continue to drive all of us forward. And in theory, we become further automated as we go. Now, the world of the cloud has exploded in the last 15 years. It's really fundamentally changed the way we think of how we build applications and way we think of application architecture. Certainly, there's Amazon, Azure, and Google, which most people know about, but there's private cloud concepts that are out there. There's Alibaba running over in Asia. There's IBM and Oracle, and of course, DigitalOcean, probably the most developer-friendly of all the cloud providers. But there's so much going on in that ecosystem, and these folks are all competing with each other every day to build better services that developers, creators, builders, architects, we can build the thing that we want. We can use that imagination. We have regained our superpower. We can type commands into the command line, code into the editor, and magic can happen on the other end. Okay? Now, I'm here to talk about some Kubernetes today. Kubernetes is obviously my favorite thing at this moment, and I'll tell you why it's my favorite thing. Okay? One, it helps me deal with all those clouds. Kubernetes is Kubernetes, Kubernetes. I love the fact that with Linux and Kubernetes, my skill set is completely portable, transparent, or whatever you want to call it, across all those ecosystems, and I love it. There's another aspect about Kubernetes, though, that's super important, and I hope everyone here gets the joke, okay? How do you pronounce that word? Well, it's Ku, Burr, Net, Ease. Ku, Burr, Net, Ease. You get it? There's a Burr in there. So they named the technology after me. No, I'm kidding. They didn't name the technology after me. It just so happens. And the funny part is I didn't know this originally when Kubernetes came out. I was like, oh, yeah, my name is in there from a pronunciation standpoint. So, yes, there's a Kubernetes. I'm actually wearing my Kubernetes shirt now. It has my face on. I don't know if I can stand up a little bit for the camera. Okay. But let me just show you a demonstration. Okay. I want to actually show you a demonstration. So let's go have some fun here real quick. What I have done is I have actually thrown up a bunch of servers across the open hybrid cloud. So to kind of give you some perspective on that, I love doing things across all the cloud providers. I'm running a bunch of servers in Australia on my Google Cloud right now. So these are actually running in Australia, Sydney, Australia. And with the Google Cloud, and by the way, I can use Google Cloud anywhere. I just chose to throw everything into Australia. I have my virtual machines running there. So these are all Linux computers that are running out in Sydney, Australia. Easy to do. I set them up just last night. I also have a group of servers running over in Ireland on Amazon. So in my Amazon environment, I've got 7 different servers running over there, over in Ireland. And then I have a bunch of things running in Iowa on Azure. So I got 8 different things running here. So the point is, I'm actually, so 8, 7, 6, what is that, 15, 21? About 21 servers running at this point in time across the open hybrid cloud, across the globe, Australia, Ireland, and the United States. And it wasn't that hard to do. A couple simple automation scripts, a couple simple installers, and boom, I got all this infrastructure stood up. And actually I have more than this running right now. Also, I'm running a Elastic Kubernetes service, an EKS instance, which is another set of servers running over on Amazon. And at times I've been known to run 200 or 300 servers across all this infrastructure. Now, why am I telling you this? It's not for bragging purposes, and certainly not to make you think, well, how much credit card bandwidth does that guy have? I have some credit cards that can handle some charges, obviously. But the point is, it's just like when back in the day when I got my first computer, I now have access to a world of computers across the globe on any part of the planet. It seems like I can launch computers and use them for really pennies. It doesn't cost hardly anything to run one of these computers, but I am now running 20 plus of these computers, and I can do that across the globe. So let me kind of show you something about that though, because these are mostly Kubernetes instances, and that's really what they are. So like I have my EKS running over here, kube control, cluster info. Let's see what it tells me. This is my EKS. I think this is running in North America. I've actually forgot where I launched it at this point, but it has a Kubernetes running there. I can say kube control, get nodes. Okay, and you can see there's 3 different nodes on that one, 3 different worker nodes, and get pods, actually all namespaces. So this is an out-of-the-box default EKS, Elastic Kubernetes service from Amazon. And there it is, right? I got that thing running. But those represent the servers that I have access to, these 3 servers, it turns out, plus these different pods that are running within those servers. And we're not going to have time today to drill down into exactly how Kubernetes works. But my point is, with most of this presentation, I as an architect, I as a developer, have this new superpower in the form of the cloud where I can launch anything I want to launch. And as long as I care about being accountable and responsible for the production side of it, I need to know how it runs. I need to have great monitoring, great observability, great understanding of that infrastructure so that I can ensure that my application behaves well in this new cloud native world that it exists. But there's that one. Okay, let's see here. Here's my Google one. Yeah, okay, so there's the cluster info. It's running in Australia. Here's my Amazon one. It's running over in Ireland. Here's my Azure one, and it's running over in Iowa. Right, middle part of North America. So again, all those things are running here. And here, let me do kube control get nodes on this one. There's a bunch of nodes there. If I do over here, well, let's go to the Google one. Kube control it helps if you spell it correctly. Get pods, all namespaces. All right. Now in my case, woo, let's spell that right. You'll notice there's a lot of pods on this other set of clusters, okay? But actually, let's do something real quick. Let's actually give you guys a URL. Let me find it real quick and let you guys try part of my application. Okay, so you're going to see in the chat, and actually the chat probably shows up before the stream does, okay? But here's what I want to show you. You're going to go to this URL, and you're going to type a message in, right? So I'll just type in my name, Burr, send request. And the point of it is when you type in your message, it's going to uppercase it. If you see the checkbox here, it says Aloha Burr, which just puts it's hello world, but it's hello world running across all three clouds. So it's running on this Google environment here that says, so your response is coming from GCP at this point. If I go back over here, this was my Google environment. But on that Google environment, what you see in these nodes is a Kubernetes cluster. So these computers, these servers represent a Kubernetes cluster. And this is what Kubernetes looks like from an OpenShift standpoint. And these servers here on Amazon, well, that's a Kubernetes cluster. Again, it looks the same here from an OpenShift standpoint. And these servers here on Azure are also a Kubernetes cluster. And so let me go to the developer view here. And the developer view here, this is the same application deployed across all three of these clouds, all three of these clusters. Okay. And so if I type in more messages here, oh, I did hit the button on the chat. There we go. There we go. There we go. Did it go? Let's try again. Oh, I'm looking at what the thing did there. It did use a link shortener. So hopefully it comes out okay. So you guys should hopefully get the link. I got to hit the right button at the right time. But you know, you can put your message in and watch what happens here. All right. So you can kind of see there's someone did a TTT for me and a blank, but you notice your messages are being responded to from Google. So let's actually go turn off the Google. That's this one over here. And let's turn off the Google backend responder. Okay. There's a concept of a pod. We're just shutting the pod down. Where am I? And you notice now you're getting a response from Azure. Okay. So your responses are coming from Azure. So what's happened is the front end application you're interacting with here has now bounced your transaction all around the globe back to the middle part of America to Azure to get the response. Okay, so the response is coming in from Azure at this point, from Azure. Okay, and there we go. So from Azure right there. Now here's what's cool. If I go shut down Azure, let's go to Azure, which is over here. And let's turn its pod off. And the pod in this case is the backend application server. It could be a Spring Boot application, a Node.js application. It could be a Quarkus application. It doesn't matter what it is. Think of that pod as the house, if you will, a highly virtualized application server. And that's what's running there. Oh, come on, Azure. Let me refresh. Sometimes when you're bouncing around the globe, things get a little slow. Let's go here and let's turn off this Azure pod. Okay. And now we're getting responses from Amazon. So we basically, because even though we're still technically running our front end on Google, we have now bounced your transaction around the globe, right? It went to Azure and now it's over in Ireland and you're getting a response from Ireland. So this uses a technology called Scupper. It's a really interesting little open source project called Scupper. You know, I'd encourage you to kind of check it out if you're interested, but this is the technology that bridges these different application spaces across the globe. And what it does is it basically takes a Kubernetes service and expands it, if you will. So the Kubernetes service is virtualized to any other Kubernetes cluster. And so it's actually pretty cool. The concept of the service in Kubernetes has now been expanded in all these very interesting ways. We're actually going to see two more ways it's been expanded, but this one allows you to distribute the service load, the load balancer, if you will, but virtualized from any cloud to any place for that matter. Okay. So, all right. So we got our Amazon. Let's bring Azure back up, but let's also bring the Google back up. And when those do come back online now still, nope. Okay. Back on GCP. So we're back on Google because the Google one is back up now. So it's actually going to go to the closest node to get the response. We're back on Google. Okay. But that concept of being able to have an application that easily spans from the Google universe to the Amazon universe to the Azure universe is awesome. Okay. And it's just Kubernetes. That's the thing I really love about it. Now, there's some things you should know about Kubernetes that we should discuss a little bit. And that is Kubernetes has this concept of a custom resource definition. So let's see here, kube control get CRDs. If I do this on my EKS here, you can see there's two custom resource definitions provided out of the box with an EKS environment. If I use Minikube, there are none. So I don't have Minikube running right now, but that would give you none. But if I come over here to my OpenShift environment, get CRDs, okay, you'll see there's a bunch of them because OpenShift prepackages a lot of these components out of the box for the OpenShift environment. And there's a lot of interesting things in here, which we don't have time to talk about in great detail. But one of the things I'm interested in is there's one called Kafka. right? So here's an element that you should understand about a Kubernetes-based architecture that I personally love. It's not just limited to the generic deployment, generic service, the generic components that it does for anything, right? For any generic pod, you can define your own object type. In this case, a Kafka broker, or it might be a pizza, it might be a beer, it could be a Burr, it could be anything. You can define your own object type. And then when you actually say, I want one of those, the system will respond accordingly. So you can see this one actually has a Kafka in it. If I come over to one of my others, like this one over here, get, in this case, virtual service, get CRDs, rep Istio, put some Istio ones in here, like virtual services. Okay, so everything you see that extends a Kubernetes backplane does it through this concept of an operator, a custom resource definition, a custom controller in many cases. So that's what we see here. We'll just leave this running. All right, but let's get back over here and let's talk a little bit more. But that right there is what you just saw. We actually basically had a single transaction bouncing from Amazon to Azure all around the globe. And we have some more links to you as links for you also. Okay, now let's get over here. I showed you that little demonstration. And by the way, I have in the slide deck, which I added the link to already, you guys have access to the slide deck and you have access to a bunch of YouTube videos where I pre-recorded some different versions of these things too. Now, Kubernetes comes from this thing called the Cloud Native Computing Foundation. They actually just did their KubeCon last week. And so they just had their main conference last week, but they have been booming inside that ecosystem. And this is just a screenshot of part of their ecosystem. I know you can't read these little images, and you're not really supposed to, because at this point, the number of open source projects and vendors that are contributing to this open source ecosystem has exploded exponentially over just the last few years. This is the infrastructure that you're looking at in order to build applications that can survive and thrive across any cloud provider, private, on-premise, out across the public cloud, out across, out to edge devices and further out. So this has fundamentally changed the world. Much like Linux gave us the ability to basically not run things on a desktop computer anymore or a tower computer, but run it remotely where we could SSH into it and then take advantage of it. But now we actually have this concept of Kubernetes, which takes that same concept that Linux gave us and explodes it out across this cloud ecosystem, making for a very dynamic infrastructure. I'm saying the word infrastructure, which is normally an operational concern, but as a developer, especially one that wants to be an architect and be kind of the person who makes the decision about all the things in a stack, you should be thinking about these elements. Now, there's a bunch of skills and techniques and tools and stuff that we could spend a lot of time talking about. And as a matter of fact, you already saw some aspect of this with skill portability. What I showed you with the last little demonstration was with the same skills, I now have the command of all those 20 different servers across those different cloud providers with the exact same skill set. The same command line tools, the same graphical user interface tools, the same things I know how to use. I now can command all that infrastructure. And I think that's amazing. I think it's a really cool superpower. And it's very much like that first moment where I got my first computer, except now I have access to the world of computers. Now, DevOps and Agile, of course, are key elements. We're going to talk a little bit more about that in kind of a fun and clever way, I hope. But one thing you should be thinking about is, are you doing things at a service, at your service? And most organizations, if you work for a large, big bank, a large, big insurance company, a large organization, you have to file this thing called a ticket. Maybe it's a ServiceNow ticket. Maybe it's something else. But with that ticket, you then wait weeks to get access to a computer. And why are we making people who are fairly expensive software engineers, software architects wait for access to a computer? They have an idea. They have a brilliant solution potentially to the problem that they've been provided. After all, we are all problem solvers here. We want to solve problems and actually experiment with things and iterate and learn and understand. We can't do that without computers. Yet our enterprise thinks we should file a ticket and we should wait. And that's true of people like Red Hat. And I'm not making fun of your organization. At Red Hat, you file a ticket and you wait to get access to a computer. It's still mind-blowing to me. But what we saw with the cloud, I just launched all those 20 servers last night on my own. Again, my credit card has the bandwidth to handle it, but you can launch just one and you have access to a computer to do your experimentation. You should also be thinking about your pipeline throughput, right? When I say pipeline in this case, I don't mean that automation thing you might be thinking of. I mean the end-to-end workflow it takes to get code that you've typed up on that command line or up on that nice, cool IDE that you have. You use your JetBrains and IntelliJ and you Eclipse IDE or whatever it is, and you pounded a bunch of code into Visual Studio. But what does it take to get that code from that person's laptop, that developer's desktop, and out into the production environment? Surveys have been done, and it shows that most organizations take about 30 days to get code from the laptop to production. And when I say 30 days, you're probably thinking, oh, that's super fast. No, in 30 days, we mean hello world. So think about that for your organization. If the business came to you and said, our key priority for the next deliverable is just hello world, and literally all it says is hello world, how many days would it take you to ship hello world? Because as a developer, you know, it should take me about 30 seconds to type the code for hello world, compile it and test it, right? It just says hello world. And I can do that through a REST API, let's say, or do it through a static web server. It doesn't really matter how you do it, but hello world is easy to code, yet it takes 30 days to ship. That makes no sense. We have to get out of that mindset where it takes so many days and weeks to ship. All right. And that's what I mean by pipeline throughput and deployment interval. You got to think about those things because the ultimate goal is to optimize for learning. The ultimate goal is to really get out there and test with a blue-green deployment, test with a canary deployment, or even something as complicated and interesting as A/B testing as an example. But we can talk more about these things, but I'm going to show you some of these things. So let's kind of get in here. I like to think about the journey. Okay. I like to think about the journey. And that journey is really where we're at when it comes to learning DevOps, self-service, on-demand infrastructure, no tickets, no waiting, automation. How am I scripting? Am I using Ansible or Puppet or Chef or CloudForms or Terraform? Or, what tool am I using to actually automate the solution? CI/CD deployment pipelines, deployment techniques like Blue, Green, Canary you mentioned. And of course, maybe at that point you're ready for microservices because microservices are super cool. Well, maybe you don't need microservices. We've actually found that people who do all the things on the left side of my chart and do them well can ship as fast as one time per week. They don't need microservices to actually ship that fast. They can actually do everything with their monolith that fast. Okay. Now, I love this concept of being on the journey so much that I've done it for so many presentations. There's the Teaching Elephants version. There's also the Wonder Woman version of this, right? So I have a lot of different versions of this in addition to the Bruce. But the point is, you should adapt what is useful and reject what is useless. All these ideas I'm kind of espousing today might not be appropriate for your organization, but you should be thinking about the bigger picture. Where can I go from a career path standpoint? Where can I go from a skill set standpoint? And more importantly, where can I make good progress, big positive impact with my organization? How do I make my organization better? Because at the end of the day, the thing we're here to do is to build better software ever faster. Build and ship better software ever faster. Okay. I love this quote from Viktor Frankl because some people in the audience, and I've had this conversation happen many times after I've given a presentation like this one, especially the keynote. Often someone will walk up to me and basically say, you know what? All those ideas, that cool thing you showed with the cloud and Kubernetes and whatever, you might have showed us today, my boss will never let me do that. My manager will never let me do that. And we're in a virtual setting right now. Okay. So this is super cool. You're sitting at your home in your bathrobe, in your underwear, watching me talk to you at this moment, or maybe you're watching this recording. Well, your boss is not in the room with you. He or she is somewhere else at this moment. Well, guess what? You can disparage them at this moment because yes, I understand that pointy-haired boss from the Dilbert cartoons is going to say, no, that's their job. No, we can't change anything. I like it slow. I like it safe. I like it the way I like it. That's the nature of being that middle manager. But I can tell you that if you're interested in these concepts, the CEO of your company does care. The board of directors of your organization does care. They want it faster. They want it more streamlined. They want better, faster software to ship ever faster. It's important to them that they actually do that. So I love the Viktor Frankl quote. If we can't change the situation, all we need to change is ourselves, our attitude, our aptitude, our capability. All right. Great story about Viktor there. Now let's talk a little bit about DevOps momentarily. Now, in the case of developers, you think your job is to throw it over the wall. The point I made earlier was that when you type the code and compile the code and check it in source control, that matters not at all. It doesn't matter till it lands in production. And it's not our job on the development side of the house to just throw it over the wall and bonk the other guy in the head. Okay. So that's not that important. And as a matter of fact, if software delivery looks like this in your organization, it's this big amorphous blob. Perhaps you've heard the story, by the way, of rolling the stone uphill, rolling the boulder uphill. Okay. Where people are kind of pushing the boulder and the boulder rolls back down and crushes us. It's an old tale, if you will. But it's like that for software delivery in so many organizations. We have this big amorphous blob, but we don't quite know what it is and what the shape of it is, but we're trying to get that thing out to production. And for some reason, somebody thinks it's their job to push back down the hill. And if you're in my development audience today, you're probably thinking, oh, I know who that is. You know, you might be thinking, oh, that's the operations team. They're always telling me no. They make me file tickets for everything. Well, no, it's not necessarily the operations team. Probably the security team is always telling you no and trying to stop progress in many cases because they have concerns. They've seen so many different critical vulnerabilities and exploits that have basically lost all the corporate data. And now every human citizen's data is out in the wild on the dark net because of poor security protocols. So you need to be thinking about security as part of your automation in your pipeline. And as a developer, we have to be writing better, more secure software. Hello world at a REST API still needs to be secure, as an example. How about this person up top here? Okay, this person, of course, is obviously our architect. They're the person in charge. They're the person trying to surf the blob right on top. They're in charge on top of that thing, but they are facing the wrong direction there. Well, that's okay, though. At least they're on top of the game. And, of course, I'm making fun of our architects, but you know what I'm talking about. And then how about this person down here being crushed under the weight of this big blob? Well, that's obviously our operations person. They're just trying to keep this thing afloat, keep it working, and they're suffering accordingly because we didn't actually build a good piece of software. We built an ugly piece of software. And here's what's really sad about this. If we do this right and we get it done and we work super hard and work all weekend and work all night, and by the way, I've been on teams that do this, we deliver it every 3 months. And we collapse. And guess what? We got to do it again in 3 months and again in 3 months. It is not fun. It is not fun at all. And the ultimate goal is to get to a point where we can deliver better software together in a cohesive way, a cohesive, nice, componentized software, well modularized. It could still be a monolithic application, but everybody's working together. A small team's working together to deliver that software ever faster. And so that's the ultimate goal. And we're going to tear down the wall between dev and ops. And you should be thinking about the entire cast of characters in your overall community, because it's not just dev and ops, it is everybody. And I purposely use these icons here to make you understand that everybody actually has a geek side to them. Because I've had conversations with people where they said, well, you don't understand, Burr. I'm the architect. I'm the developer. I can't do that thing you asked me to do because the DBA won't let me. And I responded to that person. I said, well, does DBA eat lunch? They're like, what do you mean? I said, I bet the DBA actually is a human that eats food. They eat food, and maybe they eat it at lunchtime, and you could take them to lunch. And that was a mind-blowing moment for this person in the audience. You could tell they were like, huh, oh, yeah, they eat food too. Okay. And this is important because guess what? Everybody in this community, whether it be the security team, the PMO, right, project management office, the business people, the UX people, they're humans also. We have to get out of our silos and work with all of them. And the reason I use these little superheroes here is because they're geeks also. They might love Star Wars when you love Star Trek, or they might love Black Panther in the Marvel universe, or they might think the Lego cartoons are super awesome, or they might really love Game of Thrones or Harry Potter. It doesn't really matter. There's something about those other humans that we should love also. And a key element of this is that you should be thinking in a more diverse way. You should be thinking about all the people in our ecosystem that also have net new superpowers. And if we don't leverage all those superpowers and those key capabilities, we are not building the best software and building the best teams and delivering the best actual value to the business that we actually are within. So think about inclusivity and bringing everybody in, because we all gain from that experience. Okay, let's actually show you another cool thing. There's this thing called Kafka, hopefully you know about, and I'm just going to demo it to you real quick. And just to show you one key example here, let's see, what cluster am I on here? Okay, so I mentioned earlier that this Google one has this thing called Kafka. You see these Kafkas out here? So let's do this. Let's actually put this in a location where I know where I'm at. Yeah, let's go here. Let's call this Burr. Right. Oh, there's already a Burr. Okay, Romania. Yep, there we go. And that we're in kind of a different location now. So watch, cube, control, get pods. So this thing has that custom resource definition called Kafka. The point of this is I can now give birth to anything I want, okay? I can actually start anything I want, and it's as simple as this. I'm going to come over here and grab a bit of YAML. Let's see if I can figure out where I left it. There we go. Okay, you guys can have this YAML also if you want. It doesn't really matter. But this is just a declarative environment. It's a declaration of what I want. I'm going to say cube control apply -f and give it that URL. That's all I need to do, because in that URL, it basically says, give me something called my cluster. It's kind Kafka. Here's the API version. I need 3 replicas of the Kafka broker with these listeners. I need 3 replicas of the Zookeeper, which of course is how it, at this point, version of Kafka, that's how it maintains its cluster integrity there. And I'm going to basically just cube control apply -f. And with that simple command, which I could script or even build, fancier automation around, I now have a Kafka coming to life. There's my 3 Zookeepers that are now running. After they become running, there's my 3 Kafka brokers going through their life cycle. And now I'm going to have these 6 servers. Okay, these would normally be 6 virtual machines. These would normally be 6 real computers that someone had to install, configure, and set up someplace. But now I can self-serve. I can basically launch it on my own, and you can see it come to life at that point. And actually, there's another one called an operator coming in. But if I say cube control get Kafkas, and then I can basically say there's my cluster. I can also do this, cube control delete Kafka, my cluster, when I'm done with it. So I created them, they come to life. I delete them, they go away. Now they're terminating. So just like that, I launched 6, 7 whole new servers, like whole new computers, to build a Kafka cluster around that I can now use and experiment with. And when I'm done, I can easily shut it off and turn it away. I love this concept of having that dynamic capability in the world of this ecosystem, in the Kubernetes ecosystem. Okay, we're going to run out of time here. Let's see what else we can talk to you about. Okay, let's see here. Oh, yeah. I want to show you this Istio thing real quick, because I think it's super interesting. So in the old world, we built monolithic applications. We built an application that was wholly together in its own thing. Maybe if you're a Java person, that came in the form of an ear file, and that ear file had wars and jars and everything packed in there. Those ear files were really huge, and we delivered that ear file every 3 months, every 6 months. Some people deliver it every 2 years, depending on the environment you live in. But the problem with that is a slow delivery cycle meant that we actually couldn't learn very fast, because we'd get it in production and we have to wait. Okay. The application itself, though, actually, we've had to think about it in terms of modules, components, elements. And those elements over time, we might actually start thinking in terms of microservices. And where it gets weird is where we scattered those microservices around a network. This is where it gets hard. And I'm not saying anyone should do this at this point in time. It's certainly very exciting. Everybody wants to do microservices. But when I go out and talk to people about microservices, I find most people are doing 2 of them, 4 of them, 5 of them, in which case you're not really doing microservices. You're just doing a couple different monolithic applications talking to each other, right? So really, when you start thinking about the holistic user capability and basically spreading that out across components, what does that mean? Now, microservices might have their own data. They might have multiple points of entry. Therefore, your API gateway architecture really matters in this case. And you got to think about, what it means to have that. There's, of course, multiple teams with their different pipelines and delivery cycles and delivery capabilities, dropping those components off. And all these things might apply. We've been talking about these microservice concepts for years now. But, can I make them deploy independently? Are they products, not projects, et cetera? Smart endpoints, dumb pipes, decentralized governance. Well, these things are hard. These things are actually very hard. And there's a technology that actually helps us in this case, right, called Istio. Helps us address some of these things. So Kubernetes helps us address some of this, as well as something like an OpenShift, which adds monitoring and logging and other operational concerns on top. But when I distribute these components, how do I know that I will avoid the fallacies of distributed computing? In other words, how do I deal with failure at one of these services and make sure I avoid the cascading failure? So that's a key element. So I want to actually show you a little bit of Istio. So a couple things on Istio. So let's do that. I'm going to give you guys another link. And let's see here. All right, copy that link. Yep. I think I got the right one. Nope. Let's give you guys a link. That link is going to come through before you even hear me talking about it, I think, based on the delay here. Okay, so you can see here, I have this link up, and it's just a simple little application. But what it's interesting about it is right now it's tied to this blue pod back on the server. Okay. So in other words, it's tied to blue, though there is a canary and a green, and we're not going to go into how to do a canary deployment here. But at this point, I have 6 servers up and running. So not only do I have high availability, HA, I actually have all these other elements that I can switch you back and forth to. So in other words, I can do testing and production by basically offering you the blue version. And if I get errors, I can then offer you the green version. So let's actually switch it all to green. And again, based on the delay in our streaming here, you might actually see your screen go green before you see my screen go green. So just kind of mentally handle that one there. But this is the concept. I now have switched off from what were the blues to the greens down here. You can actually tell that if I make the screen a little bit smaller, you can actually tell that based on what's showing up here. Okay, right there, see this little identifier right here? That is the pod identifier 2H6V or C2NTT. That's these two guys right here. And you know what that is? That is nothing more than the host name from the Java standpoint. So Java looked at the environment variable called host name, and that host, that computer, is one of these two. If I switch it over here to my canary ones, okay, now you're going to see it switch to these two here in the middle, the MB797 or the BK58G. Again, 2 different computers, but I'm switching dynamically from set of computers to a different set of computers, leveraging this concept called Istio. And that's a very powerful concept. So if I want to go back to blue, if I want to go back to the blue environment, and I just have a little script here, by the way, which just applies another piece of YAML, now everybody is back on blue. I make this point, which is obviously a production level concern, because if we're moving super fast, we might want this kind of deployment topology and technology so that if we do introduce a failure or something that broke in the code, the API, the configuration, we could roll back instantaneously. Okay, we could be testing that thing endpoint in production, and we could be looking for errors and roll back instantaneously. To kind of make that point, let's actually show you a different example for Istio here. Let me see if I can find it. Let's see. Oh, over here. Okay. Yeah. So let's do this. Let's see, project tutorial, and dun, 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 dun. I actually have another set of pods here called customer preference recommendation v1, recommendation v2. You can see it's actually this curl command here is just going 1, 2, 1, 2, 1, 2. Let me actually bring up my Keynote console here. All right, Keynote is an open source donation that Red Hat made to the Istio project. And let's go look at our traffic animation. And so you can kind of see that this transaction from the end user is flowing through the customer microservice, the preference microservice, and then the preference microservice has a load balancer. And this is standard Kubernetes behavior through a recommendation service to a version 1 and a version 2 of that element in production. Think of that as a blue-green deployment right there. So we're getting both because both pods are running, and both those are backed up behind a Kubernetes service. But let's actually do this real quick. Let's grab that guy and go here. Let's see, exec IT into that one, bin bash. What I'm going to do is exec into that pod. This is version 2 here. I'm in there, and I'm going to say curl localhost 8080. Okay, you can see that's obviously version 2. There's a little special command we have here on it. It's just, just for fun purposes, misbehave. And what is going to happen is you'll notice that basically version 2 now actually has a flag set that says, well, throw out 503s. And notice what happens. Immediately, we fail from 1 and 2 to just 1. Just version 1 is responding to our users now. Just version 1, the blue, let's say, or the green, it doesn't really matter what the color is responding to our users while the other one is failing. And then we can be monitoring to see that what's failing. And you can see here on my console, it already went from orange to red because 2 is failing. If I come back and fix 2, all right, and there's just another little flag to set. Let's just call this behave. All right, you're going to see it immediately goes back to 1 and 2, 1 and 2. So already our users are seeing this new version already in production. And then if we watch this for a little bit longer, you'll see it turn back to green once it knows that things are healed again. So this concept of observability is a key element of thinking in terms of making your stuff production ready, making your stuff resilient, making sure your application has that monitoring and observability behavior built into it. This, by the way, takes advantage of a certain set of technologies that I'll just show you over here called Istio, as I mentioned. I'll click over here to operators and installed operators. And you can see it's got the Elastic Search Operator. You heard from David earlier about Elastic. Elastic, of course, is how we're gathering all that data. And of course, Jaeger shows us the topology. Kiali, which is that graphical console I just mentioned, which again has been contributed to Istio project, and Istio itself living there, right? So the Istio control plane. So lots of things you can do to extend a Kubernetes architecture to do these really interesting things to make your application more resilient, make it more production ready from a go-to-market standpoint. All right, a couple other things we'll talk to you about, and we're going to be running out of time here. Okay, so that was Istio. Let's see, what do we have here? Okay, we did that one already. Well, let's talk about Knative briefly, and we'll be running out of time. But let me give you guys a couple more links. Let's go here. Let's go here. Yeah. Okay, so there's another concept called Knative. Get CRDs, grep Knative. Right, I mentioned earlier custom resource definition, CRDs, and you can see there's a serverless service. And all that really is the concept of the pod can come and go. Right now, there are no pods running up here because my thing, there's no interaction with my application. So if I come over here and say kubectl get kservice, you notice there's very special URLs there. And if anybody touches those URLs, it brings the pod to life. Okay, it brings the pod to life. So let's actually let you guys do that. I'm going to grab the URLs here and paste it in for you. And again, maybe by the time I say these things, it pops up. Okay. Oh, I see a question here too. What about Lens from the IDE standpoint? So the question is related to Lens while people are bringing those pods up. Lens Kubernetes. It's a very clever tool. I don't really use it on a regular basis because I've gotten so used to using just the command line and things like that. And there's also another one called KUI, which is pretty cool. KUI Kubernetes. So check that one out. I love both of these. So KUI. KUI is like an augmentation of your command line. It's an crazy integration of your command line and the graphical environment. Lens is a little bit more of an IDE-ish kind of thing, which is kind of clever. There's also great Visual Studio Code extensions. All very interesting to me, but I tend to keep it to basics myself just because it's a little bit easier. And it looks like you guys brought up my servers there. So you should for whomever hit it first, they had to wait a moment to wait for that Spring Boot application to come up, or that. And actually, it looks like you're still waiting on Spring Boot. Spring Boot takes a little time. It's it's a standard JVM based thing. It takes a little bit longer. Quarkus, of course, compiled to native comes up the fastest. It is the smallest and the fastest. Node.js is the next smallest and fastest. And then Spring Boot takes a little bit longer. And I'm just running a Polar down here because that Polar will keep them up and running. You can see it basically just looping there. And if you guys are hitting refresh in your browser, you're still hitting those same endpoints. But those pods, those servers, sprang to life dynamically based on user request. And I think that's the part that's super interesting about that. Okay. All right. Well, we got to finish up here and wrap up. I don't want to run us just over too much time. I know we're running a little bit late today. I thank you all for your time. You have access to the slide deck. Make sure you get access to it because there's tons of awesome stuff here. One last Bruce Lee quote here: be happy, but never satisfied. That is the key thing to understand about everything in this presentation today. It didn't matter that I started with a computer in the 80s that were paid for by a Kona coffee farmer, and that's where I got my beginning. But you can basically do anything you want to do at this point in your life. The access to those computers across the cloud is absolutely amazing. The access to a Raspberry Pi where you can learn Linux on the Raspberry Pi for $29 is absolutely amazing. You don't have to have access to a whole Linux computer other than the one that fits in your pocket. Do join us at Red Hat for Dev Nation events. Not just Spock here and Will Smith, who's hanging out behind me, and Elf, of course, my favorite cartoon, our favorite movie for Christmas, right? But you can get different sessions. You'll see Anna Maria in our chat over here. She delivers a lot of these presentations now. Lots of free learning resources. Again, if you have the link to the slide deck, which I added to the chat, you have the links to these guys here. Also, I've recorded a lot of the stuff you saw today in a very short time. I have like 6 hours of video, which you can go get from O'Reilly at that link there and go check that out. There's a lot of free ebooks, Istio information, Knative information. You saw some of that. Kubernetes Patterns, fantastic book. Also, if you're interested in how to deal with monolithic databases, and if you're interested in these DevOps principles, do check out the book Accelerate, but also all the other ones are fantastic. Accelerate is certainly very awesome. It's based on what they've been doing with the Puppet Lab State of DevOps report, and you can go get access to that report. One last thing I'll leave you with is Java is certainly not dead. My wife designed this, by the way, so I thought I should show it one more time. I've used it in different presentations. That is my Mark Twain version of Duke. I love it so much because this Quarkus concept is breathing new life into the Java community, where Java is insanely small and Java is insanely fast, but it's still Java. The way you're used to writing that code with its hot reload capability is absolutely awesome. I showed you that last year. If you want to test some of these ideas, there's this thing called a sandbox, which you can get access to also. And I think at this point, I have officially run out of time. So I thank you all for your time today.